and I am from AID branch in Kytomens. Today I want to say asymptotic notations. There are three types of notations. One is omega notation, second one is big O notation. Third one is theta notation. These are the three types of notations we have in asymptotic notations. We can discuss each one. First one is omega notation. In omega notation, there is upper bound defining time terms in time complexity. We use these notations will use in only time complexity. So for notations we have a formula Vn that will be equal to G of n. We can write this is 3n plus 2 c into n. We can write this is also, and we after writing this is the formula for omega notation, and we have to represent this notation as in graph represent. I will explain just like an example. This is f of n. So f of n is we are taking it's a fixed time. So which is given time is f of n. So this is c of n or c into g of n. We are taking the time for completing. If we are taking a code to run, it will take to just 5 minutes, but we are taking just 4 minutes to complete the code. Then this is in time to complete the code. This is C of A. We can represent this. So next one, big O notation. Big O notations is formula f of n c into g of n. This is the actual time taken. So this is the what we are taken time to run the code. So 3 of is so I can give example graph for this one also, but you should take the values here n equal to some value and c equal to some value, and draw the graph by taking the values. You can take any values and substitute the n and c values in this formula, and you have to draw the graph. But I am drawing the example. This is f of n. And this is c of g of n. So we can represent not like as t is the graph will represent, but if you are taking the values, it will take the average time, not the much time, not the minimum time. It will take the average time to complete the code in time or average time. Formula is, but here we have two times will taken, the best and arrow below case. The in between these two, the average case is there. So we are taking C1 of G of n f of n. C2 G of n. That means how we can write this formula as C1 into n f of n so we can write this formula as like this. So we can represent the graph by 3